The next one we're going to be doing is Section 4, Network Traffic Analysis Fundamentals, right? So let's go to that one real quick. Oh, that's not the right. We have to go to Help with My Course. And then we are on, we just did Threat Feed Integration, right? So now we are on Network Traffic Analysis. I'm zoomed into 200%, yep. Course, basically I'm just going to go over the learning objectives. Understand the fundamentals of network protocols and packet structure. Utilize packet capture tools effectively. Analyze network traffic for security threats. Identify common attack patterns in network communications. Apply packet analysis techniques in real-world scenarios. So when I think of how a network operates, I think of an OSI model, right? And an easy way to remember it, right, is please do not throw sausage pizza away. Please do not throw sausage pizza away. Physical, data, network, transport, session, presentation, and application, right? Those are the 7 layers in the OSI model, right? I should have done a cleaner OSI model review. Who knows, I might just look it up, right? Cloudflare has a nice view on it. We have application layer, which is layer 7. That's what the human sees, right? That's what... So I'm on the website right now. I'm on the application. The presentation ensures that the data is in a usable format and is where data encryption occurs. Maintaining connection is responsible for controlling ports and sessions. Session is for the ports and the sessions. Transport is the transportation of that data. Is it being transported securely, right? On TCP and UDP, right? Is it being over TLS, transport layer security? Or is it being over SSL, secure socket layer? Is it being transported over HTTPS, hypertext transfer security, right? So you guys know what UDP and TCP is. TCP is like three-way handshake. I give you something, you give me back something, and then I give you the thing back to validate that all the data was sent correctly. UDP does not do that. UDP, and I've used this analogy before, but UDP is like streaming. So you're streaming a video to the internet, right? TCP is sending that data, then validating that it was sent correctly. UDP doesn't verify that it was sent correctly. So the file could end up being corrupted if you use UDP, right? But it is really, really good for streaming. For internet protocol, you have IPv4 and IPv6, right? Header structure fragmentation. Module 2, packet structure analysis. We have the Ethernet frame structure. Preamble, destination, MAC, source MAC, type length, and data in FCS. So the fields we have: version, header length, type of service, total length, identification flags, fragment offset, time to live, protocol header checksum, source IP address, and destination IP address. That's how stuff is sent, right? But it also has to get all this IP information before it's able to send stuff, right? TCP header, you have source port, destination port, and that's why, like, you get those port numbers that they have to be connected to that port, and the firewall has to let you go to that port, right? If it doesn't let you go to that port, it can't connect. It can't do nothing, right? It'll give you a timeout error, right? We have sequence number, acknowledgement number, to acknowledge that they're connected, right? Header length, flags, SYN, ACK, FIN, REST, PSH, and URGE. Window size, checksum, and urgent pointer. So that's all of the, like, details that you would see and the TCP header would have to have, right? Wireshark, primary features, real-time packet capture, extensive protocol support, powerful filtering capabilities, statistical analysis, capture filters with display filters, protocol dissection, stream following, export capabilities. You can export Wireshark files, right? TCP dumps just like a Linux command, right? Or a Windows command, right? That can analyze packets as well. T-Shark is the command line of Wireshark. Network Monitor is a network forensics tool. SolarWinds Network Performance Monitor, that's just another tool, right? PRTG Network Monitor. But Wireshark is like one of the most widely used packet capture tools. One of the most popular ones, right? And these ones are like niched down. SolarWinds is niched because unless you're using SolarWinds, you're never going to use that, right? Traffic analysis, baseline establishment, anomaly detection to relate those two different vulnerabilities and stuff. Statistical analysis, right? the traffic, the bytes per second, packets per second, connection rates, and protocol ratios. Module 5, common attack patterns, reconnaissance, attacks, port scanning, TCP connect scans, CYN scans, UDP scans, detection signatures, network mapping, ICMP sweeps, ARP scanning, and OS fingerprinting. Denial of service attacks, UDP floods, ICMP floods, and amplification attacks. Protocol-based CYN floods, connection exhaustion, and fragmentation attacks. For man-in-the-middle attacks, we have ARP spoofing, DNS poisoning, and SSL TLS interception. So that would be intercepting the encrypted packets, right? But essentially being like a proxy in the middle where to be able to get to that encrypted data, that user has to go through you, right? That's how they do SSL TLS. It's not like they're decrypting it as soon as they're like getting it. You are actually going through the attacker first, right? And the way that they do that is sometimes DNS spoofing. So that to be able to get to you, the DNS server that you have to go to is the DNS server of the attacker before it'll redirect you to the real site. Data exfiltration, unusual outbound traffic, large file transfers, covert channels, and DNS tunneling. Module 6 is the filtering. In Wireshark, we have filtering. And they have these different like filters that you can filter out stuff. You can do DNS query names that contain malware, which I don't think malware domains are going to say that they're actually malware. They want to keep their self-sending, most of them at least. TCP, you can say what port you want to use, whether it's a UDP or a TCP port. Then you can do IP address, the IP address that you want to filter out. Common filter examples. Protocol filtering is like TCP, UDP, ICMP, HTTP, and DNS. Address filtering is IP, source address, IP destination address. We have TCP port filtering, UDP port filtering, and combination filters. TCP port 80, IP address, and then you put the IP address. TCP dump is a lot different. And I don't think I'd be using TCP dump, I'd be using Wireshark. Since TCP dump is more like legacy, right? What people used when they didn't have Wireshark, right? Or that they're on like a command line that they can't have Wireshark running because they don't have a graphical user interface, right? They don't have they have an operating system, but there's no like display GUI, right? But here's how they filter out for TCP dump with this Linux type command, right? Security event analysis. They have log correlation, network logs, system logs, application logs, security device logs, incident response integration, evidence preservation, chain of custody, timeline reconstruction, and impact assessment. We have threat hunting, hypothesis driven analysis, indicators of compromise identification, and behavioral analysis. We already went really in depth on threat hunting. For best practices, we have capture strategies, analysis workflow, performance considerations with the hardware, the network, the storage, and the processing power, which is like CPU is processing. Whenever I think of processing, I think CPU. Central processing unit, the part of the computer that does all the math. Practical exercise lab. We're going to be doing a lab, not in this next video, but in the future there'll be labs added to this course, right? Set up Wireshark, capture HTTP traffic, follow the TCP streams, identify port scans analysis, analyze DOS attacks, detect reconnaissance activities, protocol analysis, DNS query analysis, email traffic examination, web traffic inspection, and malware communication analysis, data exfiltration, detection, timeline reconstruction. Module 10 of CySA, key exam topics, packet analysis, and you're probably not going to be tested heavily on this, but they expect you to know how to read logs, right? They expect you to really know how to read logs, whether that be Wireshark logs, right? Wireshark, stuff like that. They're going to expect you to know that. Understand common port numbers, like port 80 is HTTP, right? 443 is HTTPS. Practice with filtering syntax. Study attack signatures. Review log analysis techniques. Just some of the additional resources, and I don't know, but some of these certification paths, right? Some of the tools, some of the reference materials. And you don't have to follow this certification path. You can do other things, right? But GAC, Certified Incident Handler. GAC, Network Forensic Analysis. But I recommend you just go straight for CISP after CySA. But if you don't feel confident that you'll be able to pass CISP, go for like other certs. If you want to go into red teaming, if you want to go into other stuff, but I think I'm going to go into CASP. CASP, right? It's sort of on par with CISP, right? But CISP is more value, but I think I'm just going to go with CASP. The CompTIA security practitioner. CompTIA security. Wait, what is CASP? CASP Plus is Security X. What is it? It is the new CompTIA Security X. It's an advanced level. So right now what we're doing is we're doing the intermediate stuff before we go into like the crazy hard stuff. But yeah, I think I'm going to be taking this one after I get my CySA Plus. And I'll be doing another full course. I'm trying to make a course right now on CySA Plus. But that is network traffic analysis. It is a critical skill for cybersecurity professionals, right? To actually be good at cybersecurity, you have to know the network side of stuff too. You can't just know every attack. You have to know how that attack could have actually been, how it could have came across the network, stuff like that. But that is it for network traffic analysis.